This video is going to be an example of how you would graph a sine function, and also at the end we're going to do a cosecant function using the standard form and using the concept of phase shift, period, and amplitude. When you want to graph a sine function, the first thing that you should do is get the standard form. And to get the standard form, I need to make sure that the coefficient of x is factored out of the argument of my function. So I'm going to rewrite this, and on the inside I will factor the 2 out of both of these terms. So remember that factoring is kind of like division. 2x is 2 times x, and to factor 2 out of pi over 2, I just need to divide it by 2. Pi over 2 divided by 2 is pi over 4. And if I compare this to my standard form with variables, this would be a times the sine of b, x minus h. And from here I can identify the values of a, b, and h, which will tell me about the graph. Looking at this, I know that a is equal to 4, b is equal to 2, and h, it's your negative h, is equal to positive pi over 4, so h must be negative pi over 4. The other thing that I need to think about is that this value of b is going to affect my period. This is a horizontal stretch by a factor of 1/2. So my period, which is normally 2 pi, would get divided by b. 2 pi over 2 would be 1 pi. This value of a is going to be my amplitude. The way that I use these in my graph is to deal with the phase shift first, the period second, and then at the end I'll adjust my amplitude. So the phase shift, h is minus pi over 4. I'll go to x equals minus pi over 4 over here. And this is going to be my starting point for my basic sine shape, which normally looks like this. So my starting point at x equals 0 is normally an x-intercept, so I'm going to have an x-intercept over here. The next thing I'm going to use is my period, and what I need to remember is that from the starting point to the ending point of my primary period is equal to 1 period. So I need to go from my starting point, and I have to go 1 full period to the right. So I'll have minus pi over 4 plus a period, that's 3 pi over 4. So that'll be my endpoint. Here's 0, 1, 2. This would be 3 pi over 4 over here. And then I can kind of fit my basic shape. I know that this endpoint is also going to be an x-intercept. Halfway in between, I have another x-intercept, that's right about here. And then halfway between the x-intercepts, I'll have a high point and a low point. So I'll just put those on my graph. And then I have 5 points, and I can kind of sketch my, my sine curve. It's flat up at the top. So I'll come down to these locations. It's not the best, but it's okay, I think. And finally, once I've done my phase shift and my period, I can adjust the vertical scale. A is equal to 4. Top of the peak is going to be at positive 4. The bottom of the valley is at minus 4. And that is the graph of the primary period for this function, 4 sine of 2x plus pi over 2. The only other stuff that I really need to do is come in and fill out the coordinates on my x-axis of the important locations. X-intercept, this is obviously at 0, so I'm not going to label it. This location was at 1 pi over 4, and this location is at 2 pi over 4 or pi over 2. The next thing we're going to do is look at how you could graph, instead of the sine function, we are going to graph the reciprocal of sine, which is the cosecant. So I'm going to do the exact same function. I'm sorry, not the exact same function, but have the exact same numbers, and I'm just going to change everything to the cosecant function. And the thing that's nice here is when you are graphing the cosecant function, the first thing that you're going to do is actually graph your sine function. So to graph this, I'll start with my graph of sine, and this is going to tell me where the cosecant has vertical asymptotes. That'll be wherever I have an x-intercept. So that'll be here, here, and here. I'll just sketch in my vertical asymptotes. once I have my vertical asymptotes, then I would just take the reciprocal of each of the y values, and really all this is going to require is that I take these little humps that are between the asymptotes and just flip them upside down. So there's one branch. I'll start here and flip this down. Oh, that part's bad. So flip that upside down, and notice that I'm following my vertical asymptotes and I'm not crossing these. So that blue line would be the graph of 4 cosecant 2x plus pi over 2.